Hello team, today we are going to have important and interesting lessons that will help you to optimize the performance of your application while working with the JPA Hibernate. We'll learn caching in JPA using Hibernate. We are going to start our lesson from learning what actually caching is and discussing cache structure in JPA Hibernate. We'll learn what first level cache is, what a second level cache is, and what query level cache is. In the lesson we'll discuss different cache providers, but in our practical examples we are going to focus our attention on the most popular cache provider that is used with Hibernate in the most cases. I am talking about Ehcache. Also, we are going to have a lot of practical examples and demo today. During the review of examples, we'll talk about different cache concurrency strategies, cache eviction policies. Also, I will explain what a standard query cache and update timestamp cache are. I will show you custom configuration of Ehcache. We'll learn persistence strategies in Ehcache. We have a lot of things to learn today. Let's start our lesson. Let's start from understanding of what caching is and why do we need it. In computing, a cache is a hardware or software component that stores data so that future requests for that data can be served faster. The data stored in a cache might be the result of an earlier computation or a copy of data stored elsewhere. To be cost-effective and to enable efficient use of data, caches must be relatively small. Nevertheless, caches have proven themselves in many areas of computing. In the JPA, caching is a mechanism to enhance the performance of a system. It is a buffer memory that lies between the application and the database. Cache memory stores recently used data items in order to reduce the number of database hits as much as possible. Let's review structure of cache in the JPA. JPA supports a multi-level caching scheme. Mainly, there are two levels of caching: first level cache and the second level cache. But as you already learned from agenda to the lesson, we are also going to learn today query level cache. First level cache is enabled by default, and you can't disable it. Second level cache should be enabled in configuration, and today I'm going to show you how to do that. The same thing is for query level cache. Second level shared cache is an auxiliary technique, mainly used in JPA to enhance performance. It is used especially during large inflow-outflow of data between the database and the application. Caching also reduces search time when the searched entity is already in the cache. Otherwise, it is fetched from the database to serve the purpose. However, when a subsequent search query is fired, it takes little time as the searched entity is already in the cache. Entity Manager stores entities for almost every CRUD operation in this shared cache before flushing the content to the database. Second level cache is complementary to its first level counterpart. Let's review each level before we will go with practical exercises. We are going to review now what a first level cache is. Entity Manager always maintains a cache called the first level. In the first level cache, CRUD operations are performed per transaction basis to reduce the number of queries fired to the database. So, for example, when we retrieve an entity from the database the first time, the data is retrieved from the database and is stored in the first level cache associated with the Entity Manager. And in case entity is modified several times within the same transaction, all changes are done in the cache only. Modification at the database level is postponed until we commit our transaction. JPA entities are cached at the persistence context level and guarantees that there will be one object instance per persistence context for a specific row of a database table. Concurrent transactions affecting the same row are managed by applying an appropriate locking mechanism in the JPA. And I have a separate lesson about locking in JPA. Feel free to refer to that lesson to learn more about locking. Let's now talk about second-level cache. This level of cache emerged more due to performance reasons than absolute necessity. In fact, adding more shared cache increases the possibility of the problem of a stale read. Stale read is a read operation that fetches an incorrect value from a source that has not synchronized an update operation to the value. As you can see on the slide, the second-level cache sits between Entity Manager and the database. Persistence context shares the cache, making the second-level cache available throughout the application. Database traffic is reduced considerably because entities are loaded into the shared cache and made available from there. We can say that second-level cache provides the following benefits. Persistence provider manages local store of entity data. Leverages performance by avoiding expensive database calls. Data are kept transparent to the application. CRUD operation can be performed through normal entity manager functions. Application can remain oblivious of the underlying cache and do its job inadvertently. Persistence providers like Eclipse Link, Hibernate, etc. have their own set of implementation created either reusing an existing one or developing their own from scratch. Let's now talk about query-level cache. The query cache can be configured in the Hibernate. The query cache is responsible for caching the results of queries. Note that the query cache doesn't cache the state of the actual entities in the result set. It caches only identifier values and results of value type. So the query cache should always be used in conjunction with second-level cache. Query cache is responsible for caching the combination of query and values provided as parameters as key and list of identifiers of objects returned by query execution as values. Note that the using query cache requires a second-level cache too, because when your query result is get from cache, that is a list of identifiers, Hibernate will load objects using cached identifiers from second level. Today we are going to learn query-level cache too on examples. As I promised you, in this lesson we are going to have practical demo and exercises. But before we start the demo, I want to discuss with you a few important notes. As always, all examples for this lesson you will be able to find in attachments to the video. Taking into account there is some specifics with implementation of the second level cache, I created a separate project for this example. Because you need to be very attentive with the selection of Hibernate version and cache provider. Taking into account we have a lot of examples in our JPA project, I created a separate project for second level and query level cache examples. You're already familiar with the JPA terminology, but to take advantage of Hibernate features in this lesson, we are going to use Hibernate API. While it is pretty intuitive if you know JPA already, still, I would like to highlight few things. Entity Manager Factory in JPA is a similar thing as Session Factory. So, when in examples you are going to see that I work with Session Factory, remember that it has the similar goals as Entity Manager Factory. The next thing, Entity Manager in JPA is the similar thing as Session. Also in Hibernate we use configuration file with different name. So, instead of persistence XML that we use in JPA, we use Hibernate cfg.xml file in Hibernate. These are the main things that I'd like to highlight. So, don't panic and don't be confused in case during the demo you would see me using new classes. I believe that now we are ready for practical examples. Let me start screen sharing and walk you through the examples that I've prepared for this lesson. So, you already understood that once Entity Manager, or in Hibernate terminology the session, is closed, the first level cache is terminated as well. This is actually desirable, as it allows for concurrent sessions to work with entity instances in isolation from each other. But today we will also learn and see how the second level cache works. A second level cache is session factory scoped, meaning it is shared by all sessions created with the same session factory. When an entity instance is looked up by its ID, either by application logic or by Hibernate internally, this may happen when we need to load associations to that entity from other entities, and second level caching is enabled for that entity. The following happens. If an instance is already present in the first level cache, it is returned from there. If an instance isn't found in the first level cache, and the corresponding instance state is cached in the second level cache, then the data is fetched from there. Otherwise, the necessary data are loaded from the database. Once the instance is stored in the persistence context, first level cache, it is returned from there in all subsequent calls within the same session until the session is closed, or the instance is manually evicted from the persistence context. The loaded instance state is also stored in the second level cache if it wasn't already there. Let's start the demo from model overview. We're going to use user model, and here it is. It is also good tone of coding to use cacheable annotation for the entity that you wanna cache. For Hibernate it means nothing, but still it is good information that this entity will be stored in the second level cache. This is JPA annotation, not Hibernate specific one. I use Hibernate cache annotation here too, and I specify cache concurrency strategy and cache region. Let's learn what a cache concurrency strategy is. Depending on what we need and our use case, we can select one of the following cache concurrency strategies. Read-only, used only for entities that never change. Exception is thrown if an attempt to update such an entity is made. It is relatively simple. It's suitable for static reference data that doesn't change. Non-strict read-write. Cache is updated after the transaction that changed the affected data has been committed. Thus, strong consistency isn't guaranteed, and there is small time window in which stale data may be obtained from the cache. This kind of strategy is suitable for use cases that can tolerate eventual consistency. Read-write. This strategy guarantees strong consistency, which it achieves by using soft locks. When a cached entity is updated, a soft lock is stored in the cache for that entity as well, which is released after the transaction is committed. All concurrent transactions that access soft locked entries will fetch the corresponding data directly from the database. Transactional. Cache changes are done in distributed global transactions. A change in a cached entity is either committed or rolled back in both the database and cache in the same global transaction. Let's get back to the user class Another property of cache annotation is region. Basically, this is the cache region. Later today I am going to show you configuration of our cache, but in short, you can configure cache regions for different entities based on your business case and how you plan to work with the entity. Another important thing that you have to remember, in case your entity has collections, we need to add cache annotation above the field separately, because collections are not cached by default, so we need explicitly mark them as cacheable. That's it regarding our model. Let me now open POM.xml file to show you dependencies that we need to make this project work. Obviously, we need Hibernate core dependency, and also we need dependency of cache provider. Hibernate second level caching is designed to be unaware of the actual cache provider used. Hibernate only needs to be provided with an implementation of the org Hibernate cache SPI region factory interface, which encapsulates all the details specific to the actual cache providers. Basically, it acts as a bridge between Hibernate and cache providers. In this lesson, I am going to use Ehcache, a mature and widely used cache, as our cache provider. We could select any other provider instead, as long as there is an implementation of a region factory for it. I added here Hibernate cache implementation, and also our solution would require Ehcache core dependency. This is just a demo with only one possible cache provider. This is the most popular one for Hibernate, but theoretically, you can use other cache providers you like. The steps to make it work would be similar. Among other cache providers that I can mention are JBoss, Swarm Cache, Ehcache, and others. In the case with Ehcache, we need to make sure that the Hibernate Ehcache version is equal to the Hibernate version we are using in our project. Now, let's enable second level cache in our Hibernate configuration file. I open Hibernate CFG XML file. Here you can see 4 important properties. They are Hibernate Cache Region Factory class. In this property we specify Cache Factory class. In the case with Ehcache, we can specify either Ehcache Region Factory or Singleton Ehcache Region Factory. So what is the difference and which one to choose? The non-singleton Ehcache Region Factory allows you to configure Ehcache separately for each Hibernate instance, using net-sf Ehcache configuration resource name property. The singleton Ehcache Region Factory shares the same Ehcache configuration among all Hibernate session factories. The next property is Hibernate Cache Use Second Level Cache. We need to switch this one to true to enable second level cache. Hibernate Cache Use Query Cache. I already told you that today we are also going to review Query Cache. We need to set this one to true to enable Query Cache. net-sf Ehcache configuration resource name. Here we specify the name of the configuration file that is going to be used to configure our cache. This property is Ehcache provider specific. Basically, these are the key configurations that we need to add in our Hibernate CFG XML file. Let's now take a look at Ehcache configuration file. I will share with you the source code of this solution, and I encourage you to look through this file slowly. You don't need to learn all these configuration options by heart, because anyway, this is not something what you will do each day. Most likely, this would be configured by analogy on your project for new cache regions. As you can see here, we have default cache configured. Max entries amount is specified, time to leave seconds, and many other different configurations. Memory store eviction policy is an important attribute in my opinion. With this attribute we can specify eviction policy for elements in cache. Because as you remember from the definition, cache should be limited in space and contain limited amount of elements. Otherwise, we won't be able to benefit from the performance optimization. And we need to have a policy which will define what elements should be removed from cache and under what conditions. Ehcache specifies 3 possible eviction policies. They are: last recently used. This is the one we selected in our example. LRU. According to this policy, cache evicts the last recently used element. The last used timestamp is updated when an element is put into the cache or an element is retrieved from the cache with a get call. Least frequently used. LFU. For each get call on the element, the number of hits is updated. When a put call is made for a new element, and assuming that the max limit is reached, the element with least number of hits, the least frequently used element, is evicted. First in, first out. Elements are evicted in the same order as they come in. When a put call is made for a new element, and assuming that the max limit is reached for the memory store, the element that was placed first in the store is the candidate for eviction. These are main eviction policies. Let's get back to the demo. Also, I configured a few more custom cache regions here. They are User, StandardQueryCache, and Update Timestamp Cache. StandardQueryCache, as the name implies, is the standard implementation of the Hibernate Query Cache interface. This implementation is very good at recognizing stale query results and rerunning queries when it detects this condition, recaching the new results. Update Timestamps Cache tracks the timestamps of the most recent updates to particular tables. It is important that the cache timeout of the underlying cache implementation be set to a higher value than timeouts of any of the query caches. And User Region Cache. And User Cache region is the region for our entity that we are going to use in our example. As you can see, these elements contain persistence strategy. Let's learn what it is and what potential options we can set here. Ehcache has a restart store which provides fast restartability and options for cache persistence. The restart store implements an on-disk mirror of the in-memory cache. After any restart, data that was lost in the cache will automatically load from disk into the restart store, and from there the data will be available to the cache. Local restartable enables the restart store and copies all cache entries on heap and or off heap to disk. This option provides fast restartability with fault-tolerant cache persistence on disk. This option is available for big memory Go only. Distributed differs to the terracotta configuration for persistence settings. This option is for big memory Max only. Local temp swap enables temporary local disk usage. This option provides an extra tire for storage during cache operation, but this disk storage is not persisted. After restart, the disk tire is cleared of any cache data. None. Doesn't offload cache entries to disk. With this option, all of the cache is kept in memory. This is the default mode. Now, let's get back to our demo again. Basically, that's all what I wanted to show you regarding Ehcache configuration. So probably now, when everything is configured, let's look at the second level cache demo. I prepared an example here for you. Let me open class that is called StandardQueryCache demo. I execute this program and I will walk you through the console output and source code line by line. So we create session factory first. Like we discussed before the demo, this is Hibernate API and similar thing to Entity Manager factory from the JPA. I created here Hibernate util factory, which simplifies creation and retrieval of session factory. There is nothing super complicated in that class, but it just helps us to save time and do not repeat ourselves writing a lot of line of codes that we need to reuse multiple times in different examples today. After that, I retrieve statistics object from the session factory and enable statistics. This is again Hibernate specific API. This class is used to track statistics of the session factory. The next thing that I do here, I create a user entity and persist it in the database. As you can see, I create session. After that, I use session to start the transaction. And again, I want to help you understand what this API is doing, comparing it with the JPA. If you saw my lessons about JPA, you can see that these lines of code are similar to creation of Entity Manager and starting transaction. You can also see here that I use save method. Save method is a Hibernate analog of persist method. Basically, this method stores entity in the database. After we created user in the database, we create separate session object on purpose to demonstrate that this is not the same session object as we used to persist our user. It is a different session object and different transaction. After that, I use session object to get user with ID 1 from the database. Load method here is analogy of find method from Entity Manager class. I use custom method printStats that uses statistics object to show us information about second level cache. Pay attention here. We print to console second level cache hit count. This is global number of cacheable entities collections successfully retrieved from the cache. Second level cache miss count. This is global number of cacheable entities collections not found in the cache and loaded from the database. Second level cache put count. This is global number of cacheable entities collections put in the cache. So, before we loaded the user from the database, you can see that we had 0 value for all these 3 parameters in our statistics. When we loaded user from the database, we have 1 miss because user with ID wasn't in the second level cache, and we have 1 put count because now this user is stored in the second level cache too. Example number 2. We again load user with the same ID, and our statistics is not changed. Why? Because our user currently stored in the first level cache in our session scope cache, and user object is extracted from the first level cache. That's why we still have hit count 0. Example number 3. Let's evict user from the first level cache vividly by calling evict method. Evict method is also a Hibernate specific API. The method removes this instance from the session cache. And after that, we load user 1 more time. Do you think it will be loaded from the database and request will be sent to the database? No. That's exactly the moment where second level cache comes into play. This time, user will be extracted from the second level cache and we will not execute query to the database. Isn't this cool? Just imagine how much requests will not be sent to the database in the scope of the whole application, in case we need to retrieve the same user in different threads. Considering the fact that second level cache is a session factory scoped cache, and is not connected with the one specific session, we will be able to achieve significant performance optimization. That's why, in the third example, we have hit count changed to 1. That's basically second level cache in action. How do you like it? Even in case you still have some questions regarding the second level cache, please leave your question in comments to the video and I will be happy to answer. Now let's review example with query level cache. I open file that is called query level cache demo. This is useful if we frequently execute a query on entities that rarely change. We already added property to our Hibernate configuration to enable query level cache. Now, for each query, we just need to call setCacheable method and set the value to true. As you can see in example, I create query object and call setCacheable method with true argument. In addition to that, we can even specify cache region, like you see in this example. That's how you can use query level cache. That's all for this lesson what I wanted to share with you. Let's recap what we have learned in this lesson. Today we learned what a cache is. We learned cache structure in JPA, Hibernate. After this lesson you have clear understanding of what first level cache is, what a second level cache is, and what a query level cache is. We discussed different cache providers, and we learned Ehcache cache provider. You saw on real example how to create custom configuration for Ehcache. Also, today we learned cache eviction policies. We discussed different persistence strategies in Ehcache and reviewed a lot of practical exercises. That's all for this lesson. I hope you liked it. Thanks a lot for your attention. Have a great day and see you in the next lesson.